to everyone from Vienna. My name is Jean-Robert Thiron. I'm a professor of economics at the University of Vienna, and it is my pleasure to say a few introductory words on behalf of the Vienna Behavioral Economics Network, or GBEN for short. The purpose of the GBEN is to bring together top academics with business people, policymakers, and essentially anyone who has an interest to discuss insights from behavioral economics and experimental economics. Our focus is not merely academic, but it is on how behavioral and experimental economics contributes to improve decision-making in business, society, and the state. Today, we have Professor David Dreyer Lassen from the University of Copenhagen in Denmark. He will first give a talk of about 20 minutes. I will then interview him and follow up on his talks for another about 20 minutes. And during this entire time, the audience can submit comments and questions, which David will then address in the third part in the remaining about 20 minutes. So let me now briefly introduce David. David Dreyer Lassen is the director of the Copenhagen Center for Social Data Science, or SODAS for short. He is an outstanding social scientist and has published in top political science journals. For example, like the Journal of Politics, American Political Science Review, or the American Journal of Political Science. He has repeatedly been an academic visitor at Harvard University, where he has done research with luminaries such as Jim Ault, who is his long-term co-author. He is, in fact, a professor of economics at the University of Copenhagen, which hosts one of the best economics departments in Europe. David is also co-director of the CEBI, the Center of Economic Behavior and Inequality of the University of Copenhagen. And if you ever have the opportunity, I very much recommend you visit the CEBI if you're a student, or especially if you're a researcher in behavioral and experimental economics, because I think it is a hotbed for top-notch empirical research in economics, and so is SODAS for social science, as we will hear later. Given his impressive publication record, you may not be surprised to hear that he has also won numerous grants, including a prestigious ERC starting grant a few years ago, and he has now also won an ERC advanced grant together with a colleague, Morten Pedersen. David has been so successful because he's a creative mind. He is full of ideas and he has the necessary energy to implement them. How did we get him to give a talk at the GBEN? For full disclosure, I should mention that I have been his colleague at the Department of Economics for about 7 years, and I am now still visiting professor at the University of Copenhagen, where I usually spend my summers. So today, David will speak about how big data and data science can be used to understand important social and also economic issues. He will present selected samples of the very innovative research done at his center to demonstrate the vast potential of social data science. So let me repeat, it is important to us to involve you, the audience, in the discussion. So please participate and write your questions to David from now on, during his talk and also during the interview. We are continuously taking notes from what you write in the chat. All that remains is to express my gratitude. Many thanks to David for being with us today. Thanks to the people from Fair Advice who have organized everything to make this event technically possible. Many thanks to all of you for being with us today. And with these words, I hand over to David, calling Denmark.
Thank you very much, and thank you for the invitation to me to come and present my research. I'm the Center Director at the Center for Social Data Science in Copenhagen, where we have social scientists and technical people, engineers, data scientists, computer scientists working together, trying to explore the benefits and the drawbacks of the new digital data that we are almost drowning in. I'm going to talk about tracking, tracing, and tagging big data and who benefits from it. The starting point of this is that we basically leave traces everywhere. We use our credit cards we post on social media, we search the internet, and we go around with phones and iPads in our pockets and bags all the time, leaving all sorts of traces that can be picked up, analyzed, and used in various ways, sometimes by services and firms that we know, and sometimes by firms and services that we know less about. So this kind of data has a number of benefits. Obviously, for consumers, it often provides free services, including map services, search engines on the internet, social media where to see what other people are doing and who they're hanging out with. But to researchers, they also provide a lot of benefits. So once you do social research, one thing you realize really fast is that people are not always super happy to provide their data. One reason for this is that it's costly, that filling out a survey or answering telephone calls may work out in the short run. But if you contact them again and ask them to do it over and over, they get tired, they don't want to participate, and that skews your sample. Second, what we get from the digital data, more or less, is what people have called honest signals. That is, they provide, if you use your credit card, well, this is what you do. But if you ask people whether you used your credit card or what they used it for, you may not always get the right answer. And finally, it's high frequency. Lots of data come only at the annual level or when you ask them. This kind of data we can access pretty much in real time and at very low time scales. It also holds some costs or challenges. One that we all know is that it has a lack of privacy. So we don't really know what happens to the data once, what is collected, say through the phone or through the social media platform. We don't know who receives the data, and we don't really know either what they're going to do with it. So this is what we call the uninformed lack of privacy. So there's a lack of privacy, we know that, but we don't really know what it means. Obviously, we know that there are corporate and political interests in this, and we also know that if you combine this kind of data with data from or inputs into artificial intelligence or algorithms, you end up in horror stories of path dependency and echo chambers where what you are offered depends very much on what you've done in the past. So the main question here is this: what can be learned from networked digital traces? So not only do we leave digital traces, we also encounter other people during our daily lives. And these kind of social networks, both people we interact with infrequently and people we see more often, either face-to-face or through social media or social networks, provide a lot of information about us. And that was really the starting point of a really big research project we started 7 years ago called the Social Fabric Project. So the point was this: there is a lot of data collected, typically by big technology firms, and we know very little about it. We know that policymakers and regulators would like some information on how to handle these kinds of services. But given that they don't have access to this proprietary corporate data, it's really hard to come up with regulation and policy that somehow responds to what's happening in these firms. So the project that we set up basically offered to all incoming students at the main Danish Technical College a free smartphone. So this was in 2013, where smartphones were still reasonably new, and especially the cool model that we offered to students was were really attractive. And most of them said, yes, we want a new smartphone, and we're going to give you access to the data that is coming out of it. So we had what is now known through the General Data Protection Regulation. We had an extensive process of informed consent. So people could at any time see what kind of data we had on them and withdraw from the study. Only one person did in over 2 years. But apart from that, we basically collected data for these 800 plus students, sometimes as often as every 15 seconds for a period of 2 years. So what the data we collected was what we could get out of the phone. So that involves face-to-face interactions through Bluetooth. If a Bluetooth scanner picks up someone in its vicinity, it included telecommunication. Who did you phone? Who did you text? It included posts and actions on social networks. And it included importantly location data via GPS and Wi-Fi, and I'm going to talk a little bit more about that in a second. So this would be the information that your phone would send out every 5 or 10 seconds in small files. And we had sort of a small attractor to pick that up. We did not at any point collect information on the content, say, of text messages or emails or social media posts for privacy reasons. I'm going to give you 2 examples on what you can use that kind of data for. The first is location. We know this from the map services that all of us use in phones and in our cars. But just to give you an example of how this is actually done and what you can use it for, I'm going to go through a little analysis here. So this map shows inner city Copenhagen, and each of the red dots is a Wi-Fi router. So when you walk the street, your phone picks up a number of different Wi-Fi signals. And when enough people have picked up a signal and at the same time have their GPS in the phone on, people with access to that kind of data can pretty much pinpoint where the Wi-Fi router is. And this is in fact how lots of us are tracked and provided information on our geographical locations through the phone or other services. This is an example of the kind of granularity that you can get with Wi-Fi information. On the left-hand side, you see a map. This is actually one of the research team members going to the technical university. You see a map based on GPS data in our setting here, collected every 10 minutes. Now you get an idea of where this person is going and a somewhat reasonable idea of how they got there and went away, but it's not very detailed. But once you open for Wi-Fi, it's possible to follow the track of our research team member in great detail. And this is, it turned out actually that lots of apps at the time did that without telling people. So not only the maps, say Google Maps, that tell you that they're going to collect this kind of information did this. We also wrote a paper on a number of apps not doing this and or not telling you, and they have since changed their policy. If you do this for enough time, you get a nice map of Greater Copenhagen. So this is the white bits at the lower right corner is the inner city Copenhagen, and the big white spot at the top is the DTU the Technical University campus. And I think it's reassuring to see that lots of students actually spend their time there. So this is the kind of information that people with access to data from your phone can get. It's not super complicated. But we also wanted to use it for something else, for something good in this case, we believe. So one of the challenge that you see in, for example, transportation research is that it's very hard to actually know how people get to work and back. What kind of transportation mode do they use, for how long, and when do they travel? The traditional way of measuring this is transportation surveys. And here you ask people at various frequencies how they got to work. But again, the problem is that people don't really want to fill out these surveys, and you can only do it for smaller populations. So what we did based on the data that you saw before is to say, okay, we combine that data where people are at a given point in time with some knowledge collected separately on people taking the bus, taking a car, biking, walking. We can actually set up a machine learning model to try to infer just from the phone signals how people are moving about. So we ended up with an algorithm that provides around 90% precise estimate of the kind of transportation people use just based on their phone. So if enough people participate in this, we can actually count with very great precision how traffic is moving and how people are getting there. In another project, we're using this information together with variation in weather to say something about how people respond in their behavior, in their commuting to weather changes, which we believe are going to be important for assessing the long-run consequences for transportation networks of climate change. In another example, we use the information we get from the networks. So in our case, people engage with other people through texting or calling, on social media, or through meeting them face to face. What we often hear is that you can opt out of sharing information, say on a social media. You don't have to share information about yourself. But that doesn't mean that the people having access to the data cannot learn things about you. What we did here was to say we collected the grades from the technical university, again with the consent of the students. And then we said, can we predict from network features of the network, can we predict whether people get a low, medium, or high grade? The graph here shows you some results. All the green bars have to do with measures that are derived from one social network. And what you can see is by far the best predictor of an individual getting bad grades is having texted or sent SMS messages with people who had a bad grade. So I can, as an individual, say I'm not going to share my information on my grades with you, but the people having the data or in general access to a social network can say, well, it doesn't really matter that much because we can infer something about who you are from who your friends are. So if you text with low-performing peers, it's more likely that you're a low-performing peer yourself. This also raises another issue which has to do with privacy. So there's a good deal of regulation, data protection and privacy regulation in the EU. But a lot of this protection and regulation pertains to data that you know with certainty. So in this case, we know if people are male or female, we know where they live or other things like that. But once you get into individual characteristics or data points that are estimated, it's a little bit more unclear whether this is actually personal data. And whether they have, in the case of social networks, whether they have to tell you that they are trying to infer who you are based on your friends' characteristics or behaviors. So that is a current challenge for using and abusing this kind of data. What I would like to do is to show you some examples of analysis like this, or based on methodologies like this, that we used during the COVID-19 lockdown in Denmark to say something about how people were moving around, to say something about how people cope with the crisis and whether they needed help or were helping others, and also a little bit about what people felt during the lockdown. So the first example I'm going to show you is something that a team at the Danish Technical University and people from our center did. Was what they wanted to do was to map where people were day to day during the lockdown. So one of the things that is very important when you have a pandemic is to know if people interact, and one way of knowing that is knowing where they are. So what the problem is in general, and for privacy and all other sorts of reasons, we actually don't know where a given person is at a given time. In this case, it was less important to know who people were, but rather the number of people. What this map shows you is Denmark from above, and they use data from something called Data for Good initiative from Facebook, where Facebook provides for free data on aggregations of individuals. So there's no individual data in here, but they count, in this case, how many people log in from different places in Denmark. What you're seeing here is gray, red, and green bars. The gray bars says that, well, the number of people who logged in there was the same as it usually is. The red bars showed a large drop in the number of people logging in, and the green bars showed a large increase. So this is from the weeks following the lockdown. And what you're seeing, and they did this basically in real time, day to day, and sometimes even intraday, you could see the movements from the cities into the countryside to summer houses, and this kind of information actually informed local municipalities outside of the big cities of whether people came to stay and what they had to do in order to keep everything right during the first weeks of the pandemic. Another example, also from Facebook data done from our group, is to look at how people cope with the sudden stress of not being able to go out, not being able to shop to a great extent, and all the other kinds of restrictions that were put on people with the lockdown. So what they studied here was civil society. So the state helps in one way, people help themselves in other ways. But what we also saw was an explosion of help groups coordinated on Facebook. So the day after lockdown, there were 56 Facebook groups established coordinating demand and supply of help and assistance. After 3 weeks of lockdown, there were more than 250 groups countrywide. And so the map you see at the top right corner is all the blue dots are help groups around Denmark. And these groups are really important for people who need help to do shopping, for example. It's not, obviously not everyone is on Facebook, but in Denmark actually a surprisingly high number, more than half the population is on Facebook. And lots of people know people who are on Facebook if they are not themselves. So they could get help for shopping, they could get emotional support. There was a little bit of donations, but also help with transportation and childcare. So I believe this provides an interesting sort of prism on what happens in a national, or in this case, international catastrophe, that not only does the state, and in Denmark's case, the state was very prominent in what it did, not only does the state help out, but people do arrange for decentralized civil society solutions. The final example I'm going to show you has to do with emotions felt during the lockdown. So how did people perceive the lockdown? What were their emotional reaction to it? And this kind of analysis, it's based on Twitter data, has a reasonably long history. I think it's more than 10 years ago that a research team measured the mood on Twitter. This was for the US, where lots of people are on Twitter. And they could, through reasonably simple analysis, really see the extent to which the national mood in the US changed with weather and such like. So what they did here was to do first simple so-called sentiment analysis, so were people feeling positive or negative emotions based on the text they tweeted out. But in this case, what is positive and negative in a pandemic and in a lockdown is actually not all that clear. So they took all the tweets, this was based on all the tweets from Danish users. And then they took a subset of these and said, okay, now we're going to analyze this like true sociologists and anthropologists. And then they looked very detailed at a number, thousands in fact, of these tweets to give a more fine-grained analysis. What was the positive and the negative emotions? What were they about? Were they about people trusting? Were people angry? Were they frightened? And then once they had that for this small subset of data, they could project that or amplify that back into the entire data set. And this is what the graph shows. And one of the things which is, I believe, striking is that, so everything here is compared to the last week of February. So what is striking here, I believe, is that you see a large increase in people expressing trust during the lockdown and also across the announcement of the reopening. This is by far the most prominent emotion. And this is, to some extent, at least, a testament to the Danish sort of reception or acceptance of government policies. I believe that there was a large degree of trust in the government and in the health authorities at the time. What you also see, obviously, is that a lot of people also express other emotions, sadness, anger, but people who were really frightened, at least expressed on Twitter, actually decreased dramatically once it turned out that, at least for Denmark, that the lockdown was maybe working, and that the pandemic, or in this case the virus, was somewhat under control. So this is an example of where you can combine, if you will, traditional social science analysis, qualitative data analysis, with these more modern, large-scale Twitter data.
Thank you very much for a great talk, David. These were, I think, very exciting examples of innovative research. So the first thing I would like to come back to is your example from transportation research. So I think this is a fantastic example because it shows the advantages of this data science over conventional approaches where you have to make people fill out these surveys and they're incomplete, or people don't like to do it, they're inaccurate. And this data is so detailed, apparently, perhaps you can explain a bit more, that you can actually from this data infer what type of transport mode people use, so whether they use the bus or the bike. And also, you mentioned that you can actually see when the weather changes, say it starts raining, which is not untypical in Denmark, it starts raining, and then whether people, I guess, switch from bike to bus. And then from these responses, you say that this is valuable among other things because it will tell you something about the adaptations people will make to global warming. So to what extent can these data from weather be extrapolated to other things?
Yeah, let me start with how to measure this. So what we did actually was, in addition to having all these students just running around Greater Copenhagen with the phones in their pockets, we also did some very detailed studies to establish what we call ground truth. So we had another army of research assistants with the phones in their pockets, and every time they used some kind of transportation, they noted on the phone what kind of transportation they used. So we knew that when the signal was like this, we knew this was equivalent to a bus or to a bike or whatever. And then we used that ground truth to train a model. And then what we did was to put that on top of all the phone signals from the students.
So you don't rely that they do this every time. It's sufficient if they do it sometimes to indicate the mode, and then you can.
Yeah, and actually, this was not the technical students at all. This was people we basically hired to do this in detail. And they did this for I think 4 weeks or so. And then we used that to say, okay, how can we estimate, or with what precision can we estimate, if we just got the data from your phone or from my phone, without really knowing what we were doing in terms of transportation. And this is where we ended up being, not perfect, but pretty good at, especially distinguishing, self-motoring on the one hand, walking, biking from motorized transportation, but also the bus versus car, which is of course really important in pretty much any big city in the world.
Okay, so the accuracy is very high of the model, so you can very clearly predict what mode they use. But what can you predict with it? If you see the weather change, how good can it be for climate change?
It's obviously better in bigger cities because there, I think it would generalize to most bigger cities. You would need to train the data on the local setting because in some countries you use mopeds or scooters. In some countries you don't. So there are different ways of different types of transportation. But that's not too difficult, I think. So that part of it is fine. On the weather part, I agree with you that we cannot estimate what transportation in 2050 will look like from the data that we're having here. But I think what we can do is to have some idea of the transition. So everyone speaks about the green transition. And in fact, last week there was a major report on the future of transportation in Denmark. Should there be more electric cars, all these kinds of things. And in order not, everyone knows what the end point is. That's something to 2050, but getting there is the big problem. And this involves a lot of behavioral responses at the very micro level. Do you take the car? Do you take the bike? Does it depend on the number of places you can recharge your car, etc., etc.? And stuff like that, I think we can learn about the transition path from what we're seeing here. And the results we had on the weather were not super surprising. If it's bad weather, people,
Sure.
they show up late, they don't come, or they take a car or bus, right?
Okay, let's move to the second topic. The statement is somehow, if you interact with low-performing peers, if these students interact with low-performing peers, it's more likely that you are a low-performing student. So it's a fascinating finding, perhaps on some extent it's not totally surprising. What is actually the scientific value of this type of findings? Because these are correlational findings, and often in science, at least the people who do experiments, we try to uncover like deep structures, causal mechanisms. We try to test hypotheses. This is how we advertise experimentation, whereas this seems like more correlation. And to be a bit provocative, is experimenters would tend to say, yeah, big data is great, but big data is dirty data. Essentially, because with the dirty data, you have this kind of uncontrolled data generating process, and it's really difficult to infer any causal mechanism. So how useful is this from a scientific perspective? Question one. Question two, if it's not so, even if it's, is it actually also useful from a policy perspective? Because even in a policy perspective, you would like to know what is the causal mechanism, because so to know where to actually, to clamp down on a phenomenon, you need to know where to put the lever. So
two or three parts to the answer. So first, it is important, I think, but maybe more from a regulatory or policy perspective towards the tech industry specifically. So part of what we were interested in this study is what can you learn about people from their phone? So if you are a company that has access to people's phones, what can you infer about them? And how can you monetize that? And it turned out, one of the things we found out was that it was certainly not only Facebook or Google that tracked what happened on the phone. It was all kinds of apps, which meaning that all kinds of producers of apps would generate data sets at the individual level that they could then either use themselves or sell on. And this is correlations, but in order for us as the public, or in order for regulators to have any idea of what's going on in these corporate data troves, they simply need to know what is the kind of data that you can get and what is the kind of information you can get out of that data. So if you look at this from, say, Facebook or any other of the big tech companies, they're not that interested necessarily in causal processes. If they can establish a nice correlation and make money off that, that's fine. But it's important for, say, for privacy, what do I disclose about myself that I know what they can use this kind of information for? And think about so Facebook recently was proposing to launch a new currency, the Libra. And why would they be good at that? Because they would be really, really good at credit scoring people, because they know so much about them. So all of a sudden, your relationship to your bank depends on signals about who you interact with. And if you were a regulator, say a financial regulator, you would certainly want to know how they score their customers. So from that sense, this part of the study was not about establishing causality, but it was about saying, we want to do what they do to see what kind of data, what kind of inferences they can make. But that being said, I think one of the things that you also can do is that you can combine the kind of data collection, say via the phone or via Facebook or via credit cards, etc., with the standard experimental methods. And we actually did this as well. So what happens at the Technical University in Denmark, where we did this study, is that they allocate people when they start into groups that are basically the social focal point for the first couple of years probably. And that has worked very well for them for a long time, but the allocation process into these groups is, it's unclear, and it has never been meant to be measured, but we were allowed to randomly allocate people into groups. So we actually have some control over these social groups. The only restriction was that we should put all the vegetarians in one group, but otherwise it would be too annoying when they were going groups. But other than that, it actually, we had full control. And that meant that we could use these methods then to study the micro interactions, the causal effects of some of these group level randomized settings. And what was interesting there is first, and I mean this is not guaranteed, but the groups worked as intended. So if you got into a group randomly allocated, you would spend more time together, both offline and online. And that is an important thing when students, should continue studying whatever they started on at university. So that part was interesting. The other part, which was also interesting, and that we could compare to other places also where we've done this, is that it decreases what is known as homophily or sorting. So often you interact with people who are like yourself. Somehow people who are from high income or low income background, they sniff out people like themselves, and then they hang out together. You see it also very much in terms of gender, especially at a technical university where there are not that many women. So once you have these mixed groups, we can see this decrease, this sorting substantially, which I think is not a bad thing, to meet people who are not like yourself. So there is, if you want to engineer social groups, you can actually do that to some extent. And right now we are, so the reason it's not in the presentation is that the paper's not out yet. But we are actually right now working on the longer run consequences of this. So we can follow people. They are now out of university, many of them, and into their first career. So are the career choices across individuals correlated? So if you come into a group with children of many entrepreneurs or startup parents, is there a greater likelihood that you become one yourself? So issues like that, because we can actually track them. And I actually have an interesting anecdote on this. So in the late 60s, my uncle started studying chemistry at the University of Copenhagen, and they were ordered in the lab, the students, by last name. And he got next to some random person with a last name close to his. And now they have actually, so their families have actually lived together in the same house for 50 years. So, you know, random interaction engineered to some extent by this randomization device can actually have profound consequences on your life. So if we could track something like that, that would be wonderful.
That's fantastic. I think it's, well, on the one hand, you can say, okay, it is possible to generate random friendships, so to speak. So you bring together people which you would not have sniffed out, as you say, but somehow, given that they're there, you discover things. I think that's a very interesting finding. And of course, it's also plausible that if you mingle with entrepreneurs, that you're more likely to become an entrepreneur. I guess that's why people pay a lot of money to go to these elite schools, to have some, or is one of the reasons why places like, I don't know, St. Gallen or so would not want to have everything virtual because you want to mingle with these people. So you're also, I should also mention that David is very prominent policy advisor. Actually, he advised the Danish government and other ministries and other very prominent advisors. So let me come to the third topic. The COVID is, of course, a hot topic. Many fascinating examples that are related to how people moved. So they moved out of the city to the countryside, to the summer houses, that they helped each other out. And the third one is the mood. So the text analysis of these messages sent on Twitter shows that people were more trusting after the lockdown, were more trusting and had less fear. So these are all, I think, very fascinating examples on a hot topic. And somehow that makes me think, are we moving into something like real-time social science? Yeah. So in the normal production process in social science is, you know, you write an application and then you hire someone, you do the study, and then you have the ethics board first, and then you write the paper, and then you go to 3 revisions, and finally 10 years later, the paper is published. Or this is what happens to me. So this seems like real-time social science, and perhaps you can comment a little bit on that. But I have another question that perhaps relates to Denmark. So this is in many ways a very special country. It's a high trust country, has a well-functioning government. So perhaps what you see here might be different in Colombia or in another place. So in surveys. So I wonder, to what extent do you think does it limit the value of these real-time studies? Does that mean we have to do it everywhere? In Colombia, in each country we have to do this, or is there some generalizability? So that would be my question. And then perhaps a more general question on Denmark and empirical science. So Denmark in some ways is the nirvana for social scientists, especially those that want to work with micro level social data. In these, and also in other Scandinavian countries, the researchers have access to very detailed micro level data. So I wonder, what's the relation between these very high quality microdata you have in Denmark, and there's a whole industry of people working on these microdata. On the other hand, we have these very attractive big data, which has very fine granularity. Every few seconds you get a signal from the phone. What is the potential to combine these things for social science? Many questions again.
Yeah, many questions, but let's start with the real-time social science question, which I think is very interesting. And there has been for some time, of course, an interest in what I think in finance and prediction they call nowcasting. So rather than forecasting, if you can somehow get an idea, rather than an estimate of GDP in 3 or 6 months' time, if you could get some idea of what it is now, it would be worth a lot to decision makers, certainly in times like this, but also in more normal times. So there is an entire sort of industry trying to measure key variables in using, searches on cars, on Google, or sentiment indices from newspapers, etc. So that is going on, but it has probably not been applied to sort of more general or standard social science measures until now. And there was, I don't think we've seen, at least in my lifetime, a demand for knowledge about ordinary people's behavior in the way that we have needed it now. And we were not, prepared super well for this. But once things got going, it actually turned out that there were a lot of data sources where we could follow things like this in real time. It's also important to say that it has not meant that surveys are not used anymore. So a lot of the research that has been going on has also been surveys of the very traditional kind, with the problems and benefits that this has. But being able to supplement with this kind of data, I think, has actually informed policy in many countries, with also the informed commentary of social scientists on how to interpret what's actually going on. And one step away from that, I think some of the things that I presented to you made in the center here is very close to published, or some of it is published already. So there has been a speed up in research funding, in publishing, etc. And there's been some discussion in the academy on whether this is a good or a bad thing. Will some stuff get out that is not
replicated,
which is a fair concern. It's also meant also a popular interest in these so-called preprint archives, so where people put their research before it has been vetted by reviewers. And we have seen examples of very strange papers turning up on these preprint servers. So there's the entire sort of scientific production model has been challenged a little bit, and I think it's interesting. But I do think it's really interesting that you can see, current papers on current affairs in economics being published, very fast after the fact. So there has been some papers on studying, spending, for example, which is basically in real time, and that's in very good journals. And given what you just said, that sometimes in economics it can take 10 years for a paper to appear, that is something that's worth looking into, and something that the sciences and the health sciences are much better at, because that actually matters if a new paper on some medical science fact comes out now or in 5 years' time.
Or perhaps you can comment on this, on the nirvana for social science in Denmark. So we have these micro-level data. You mentioned the connection to survey data. How do you envision the future of this data science approach and microdata or other conventional approaches?
I think we're seeing some of this. Some of the studies that we are doing have in fact been a combination of the behavioral data that we had from the phones, and then the sort of more classical micro-level data available through the proper system, if you will. So it is possible, if you get people's acceptance of it, to combine these kinds of data. And you need the Danish Central Person Registry number to do it, which is not something people part with very lightly, and neither should they. But if they do, and all the students here did this, then it is actually possible to sort of match the high frequency data onto the very sort of, it is very high quality data, and the data is typically what we call third party reported. So it's reported by the tax authorities, not people themselves, or by the banks and not people themselves. So that is a very attractive a feature of these data. So I think we're seeing some of it. And we're also seeing that, by the way, you have done work like that on combining experimental data with these kinds of registers and work on survey data. So it's coming together, but it's, so I think we're going to see a lot of interesting work. And one thing that we're actually doing right now, we're saying, okay, we have all this behavioral data, we can predict lots of things with that. But what if we had the other administrative data instead. So Facebook does not have the administrative data, or Google does not have the administrative data. They only have the behavioral data, and this is why they use that. But it's terribly privacy invasive. So one of the things that we've looked at is how well can we predict drop-off in this technical college. And we can use the behavioral data, and we get a pretty good prediction of who drops out based on the patterns of mobility, transportation, whether they show up for class, etc. But then if we take basically the history of their school grades in high school instead, then we can predict much better. And if we add the behavioral data, we get nothing. So everything we see in the behavioral data is already contained in the school grades. And the interesting thing is that people already report their school grades when they apply, because this is how they are admitted into university. So somehow we're seeing, suppose you as an individual could choose between what kind of data you would give out about yourself. Would you give your whole life on your phone for 2 years, or just your high school grades? I think I know what I would choose. And this is the kind of, you need both kinds of information in order to be able to assess this. So that's also something where you can actually say, well, maybe this invasive data collection is not really needed. Maybe we can get around or give companies the same kind of predictive power, but with less privacy invasive methods.
Excellent. I think this is a very provocative or thought-provoking statement. Thanks for these explanations. I could go on like this for hours. It's very fascinating stuff, but I think it's now time to involve our audience and to bring in some of the questions that we have recorded along the way. So let's have a look. First, I'd like to there were several comments related to the title of this event. Who benefits actually from this? So obviously, many companies are very eager to collect this data. It is sometimes said that the data is the new oil, is one saying. And so there were some comments. Peter Helasi, for example, said, is this type of research you are doing, whether that is somehow commercialized? Are you making money of it? Is this more for policy advice? That was one question from Peter. Then there was Beatrice, who asked, how can we make sure that this data is actually used for ethical goals? So what is your motivation? What are possibilities here? Would it actually be unethical to make money out of it?
I think from this particular research proposal, it would, I guess, be unethical in the sense that we actually promised, at least for a first pass, the students that we would use the data only for research. So in that sense, it's certainly not something, that we would give away in the form of data. And the second part to that, I guess, is that I'm certainly not a businessman myself. So I have no sorts of, certainly not sufficient imagination to make money off something like this. So what we have been is in contact with municipalities, for example, across Europe, larger cities who would like to have some kind of more detailed measurement of how people move around.
So a follow-up question was asked by Shripriya, how this can be used to study gender inequality, poverty. Isabella asked in private to me about how to use it for stereotypes. You actually mentioned some things in the connection of the DTU students, where there are only few female students, how they mingle, how the girls interact with the boys. Do you have any comments or how this type of research can be used to study this type of question? Perhaps also outside of Denmark, whether it can be used in third world countries, perhaps?
It is, in fact, studying gender segregation, for example, is pretty difficult. So what you can do is you can look at different occupations. Are there many men or women in that occupation? But it's much harder to study this at what we would call the micro-sociological level. So who do you actually interact with? And we're also doing that actually on Danish Facebook data, where we see a very high degree of genders basically talking to themselves to some extent. And that's something that is really hard to measure otherwise. And you could do this pretty much in any country. But on the poverty and on the third world country applications, this is actually a very interesting and very active research area. It's not something I'm doing myself, but it is interesting that for example, in most of Africa, you never really got landline telephones because it was expensive, it was hard to roll out. So in Africa, they basically skipped the landlines and then they got mobile networks much earlier. So many people in Africa have a mobile phone. And there's some very interesting research coming out of, I think, Berkeley, using mobile phone data and the history of data you can get from mobile phones to estimate, for example, whether people are poor. And that means you can also estimate to some extent the distribution of wealth in a country where it's typically super hard to measure anything at all. So some kind of idea of the wealth distribution in a low-income African country is something, say, the World Bank likes a lot. So there's a lot of interesting work. But that also, I mean, given what we've talked about already, it is interesting what smart people can get out of signals from the phone. So it's not only where you are, it's also how much money you have.
Right, thank you. Let's come perhaps a bit to the topic of privacy. There were several comments relating to that. So it was kind of interesting that you said, if I had the choice whether I would provide information on my grades or, hand my life on the phone, there's less information in the phone than in the grades. That kind of sheds a new light on what is actually sensitive data, perhaps. So that would be one question. So can we learn something about what is actually sensitive data? Then another topic that was raised by the audience was abuse by the government. So China was mentioned. I mean, in a way, you did this with tracking 800 people on the phone with benevolence, and they all agreed to this. The Chinese do it with 800 million people. And, in what ways is this scalable, or, perhaps you can comment a little bit on that, on the danger of abuse. And the third topic that was raised by Mark was the COVID tracing apps, which are now popular or thought to provide a possible ally to combat the spread of the virus. How can we make sure this data is not abused? It's related to the Chinese question, perhaps.
Yes, it is. So maybe let me start with the final one. It's a little bit related also to the transportation example I showed you, is that in some cases, say in transmission of COVID-19, but also in transportation, we're actually less interested in who people are, but just the fact that they go by bus or that they have the virus or they don't have the virus. So in that sense, it is possible to decouple, the point of interest. Say, do you have the virus or don't you have the virus? Are you on the bus? Aren't you on the bus? From who people are. And what we do in the transportation studies is that we can, rather than follow, say, me from my street door to work, we can chop up my trip into several smaller segments. So what we're interested in is not David going from home to work, but it is how many people is on a bike on this street at this time. So in that sense, by chopping into segments, we get around this concern that you can re-identify people, and people may be going places they didn't tell their work or their family or whatever. And the same thing with the COVID-19. Actually, one of the people in the European task force on the COVID-19 was the technical mastermind behind this study, Sune, who was at the Danish Technical University. And they pushed hard to find a solution based on Bluetooth that is anonymous. So it's not interested in who owns the phone carried by someone with a virus, but only the signal that there is a virus near you. And I think they actually managed that to some extent, but still it's hard to get people to use these. There was also the question, what is sensitive data in the first place? And that is tricky. That's super tricky. So there was a study some years ago. It was it set somehow the stage for Cambridge Analytica, which later was this firm that was involved in a scandal based on Facebook data with political advice. But what the academic article showed is that it is possible from not too many Facebook likes, not too many comments on Facebook to estimate, what we would typically consider to be pretty private data. So data on one's sexual orientation, political orientation, personality. All these are types of data that, if you look at the European regulations, fall under sensitive data. And it's something that people rarely have or part with, but it is actually something to be estimated. So if you are one of the social media platforms where people engage in liking and resending or retweeting, then they can actually estimate with a considerable degree of precision something about you that we would typically put, on the very top shelf in terms of data regulation. So that is an issue. And I think, and this is related to the China question, so it is tricky business in a sense. So the research that we are doing is that facilitating others doing unethical things, or is it facilitating, the community being able to actually know what's going on in China, in the big tech companies? So there's a little bit of the hen and egg problem here. I'm pretty sure that we're a little bit behind, if not a lot behind, Google, Facebook, the Chinese government for that matter. So with that perspective, I think it's really important that we as researchers manage to study what they know and what they can do, rather than stop doing something like this altogether and just leave it to unchecked powers.
Okay, the center you're heading is called Social Data Science. So I was wondering whether you could comment a bit on this new discipline. So especially in the combination with social. So, the typical idea, stereotype we had of a sociologist was perhaps, specific, but it was probably not the guy who studied lots of math and statistics and computers. We now see that you can do address a lot of interesting questions in the social science or to understand societies, but you need these skills. So I was wondering, how did you set up? Are you inventing a new discipline? How do you set up these courses? What's the acceptance among the students? Do they have to learn these tools? I mean, do they have to learn to program, to do the statistics, the math? And perhaps just a tiny provocative question. I mean, social data science or data science is all the rage currently. People talk a lot about it. They think it's fancy. Is this just a fancy word for statistics?
In a way, I guess it is. So someone said once that data science is the sexiest job of the 21st century, and everyone wants a sexy job. So two parts to the answer, I guess. One is that so there were two reasons for doing what we're doing. One, and that relates very much to the teaching, is that this was to a large extent student-driven. So what happened when we began this project that you've heard about on the phones, it turned out lots of students turned up and said, "This sounds really interesting, could I be a part of this?" And it also turned out that many of these students had actually taken courses either at the Technical University or at one of the online platforms in machine learning and in courses like that were not available for the social sciences at the time, 6-7 years ago. And that meant they learned machine learning to study, pork meat production or windmills or whatever it is you use machine learning for, which is very fine, but that is not human beings who act in different ways and where you have to be careful of different things. So that was really sort of the big important jumpstart for us to think about, should we have a course like that? Should we have a program like that? Because there was certainly a demand. And the second part is, in a way, our professional motivation was also taking our social science back from the data scientists, or from the statisticians and computer scientists, because there is a movement that, you know, as a physicist or data scientist, you can analyze anything you can get your hand on. But that's not actually always true. And there is actually something that the social sciences have thought about that is not something that you just pull off the shelf as a physicist or as a computer scientist. So in order to empower, if you will, us and the students to participate in that discussion, I think it's really important to upskill or to upgrade what we can do. And that being said, you know, it's hard, but it's not super hard. And if you are, you know, below 30 years of age and you have a smart computer, then you can get very far.
Wonderful. I think these are a great comment to close the discussion. I think this was a call for young people, not only for young people, but mainly for young people to get interested in this field. I think this is a fascinating new discipline that comes up. It's actually interdisciplinary. It opens up exciting new fields. I guess it's also great on the labor market that these people are very much sought after in the job market. So all that remains to me is to thank David for a great talk, very inspiring. These topics will keep us busy, and we will follow you on the internet. SODAS is the name of the research unit that you should Google every now and then to follow the new research of David. So I would like to thank you all for having shared the discussion, for making comments. I'd like to thank people from Fair Advice for having made all of this possible, and hope to see you around in the next event. Bye, everyone. Thank you.
Thank you very much from me as well. Bye.